Okay, we will start today by introducing some instructions for this webinar. This is an interactive session. At the end of the presentation, there will be time for questions and answers. Also, please remain muted during the session and keep your cameras off. The last point that I would like to mention is that this session will be recorded, just for you to be aware of it. For today's agenda, we'll start with a short introduction to the webinar's topic, followed by the DSS presentation. During the presentation, advanced features of the library will be presented, and in parallel, if you have any questions related to the feature being showcased at that time, you can use the chat and ask your questions. At the last part of this session, we will dedicate a few minutes for discussion and also to answer your questions. Now let me present our speakers for today's webinar. Mr. Apostolos Apladas, who is the eSignature product owner, and Mr. Pierrick Vanderbroek, who is the DSS lead developer. Now I will give the floor to Mr. Apladas just to say a few words, and afterwards Mr. Vanderbroek will start the presentation.
Sorry, Tolis, are you speaking? I think the volume may be quite low.
Is it better now?
Perfect.
Okay, I just switched the headsets. So I will start again. I was saying that I closed my camera because we instructed to do so by our colleague Sofia. And thank you very much, Sofia, for reminding us. And today I would like, first of all, to thank everybody for being here, that you found time in your calendars in order to attend this webinar, which is a continuation of a series of activities that we conduct here in European Commission and DigiDigit. And in the e-signature building block, we are performing a lot of activities. We supervise the trust scheme in Europe. We collaborate very closely with the member states in order to maintain the list of trusted lists, the European Union's list of trusted lists. And one of the core business that we are performing here is this open source library, which is called DSS. And most likely all of you have experienced DSS and you are using it or you are planning to use it. We have managed the past years to evolve the DSS library heavily in order to have it as the backbone of the European Commission signing service, as well as European Parliament's own signing service. So DSS is actually the engine, the core engine of the signing service of two major institutions, which this means that in real life we face a lot of challenges. We have very heavyweight operations and processes that with the help of DSS we are able to deliver a very good service. And this is the reason why we believe that by using DSS from your side, you will benefit first of all for having a very good engine for your own signing platform, which is compliant to the latest ETSI standards, as well as even the revision of the eIDAS regulation. Today, my colleague Pierrick is going to tackle some advanced topics on the features of the DSS library. And I would like at the end, towards the end of this session, or as a follow-up, if you don't have any objection, to contact you in order to ask you what will be your impression in case you would like to see a presentation from our side hosted in a person-to-person setup without having this webinar, and also having some other activities like a bug bounty. DSS was participating 2 years ago in Digits Hackathon, where implementers of the DSS joined us for 2 days in Brussels in an attempt actually to try to discover the bugs. So these are some activities that we have in our mind, and we would like your feedback in order to see whether it makes sense to organize such events in the coming future. I wouldn't like to take over the floor for more. I would just like to give the floor to Pierrick, pass the floor to Pierrick in order to start immediately with this webinar. And nevertheless, I'm going to be here the whole during the whole meeting in order to discuss further if needed. Thank you very much, everybody.
Thank you very much, Tolis. My name is Ben Vandenbroek. I will present you some features of the DSS framework. For that purpose, I prepared some code snippet in Java. Do you see my screen? Yes, okay. So I prepared some Java code based on the DSS 5.8, so the last stable version. If you have any question about the different sample, you can ask the question directly in the chat. And for remaining question, we will see at the end of the presentation with a question and answer session. So here I prepared several samples. So all samples are completely independent. So the first one is about JACB module. So if you already know the DSS framework, you probably already know that DSS offers several specification modules. So I can show directly on the GitHub, for example. You have several modules which contain JACB object, and all these modules are following the same structure. If we take, for example, the spec ZS, in the jar file, you will find the different ML schema from the HC standards. And with this module, you will be able to load this XML schema and parse any Gss file into a JACB object. And with this object, you will be able to modify or save a new version of your object. I will show now in my code snippet here how to do with a trusted list, for example. So here I'd like to use my spec trusted list module to load a trusted list, then to edit it, and finally to store my modified file into a new file. So for example, here I will load a Finnish trusted list, and with the trusted list facade, I will be able to unmarshal the file, so it will load the file in the memory and then build JACB object with the trusted list content. And then with this object, I will be able to modify the content data. For example, here I'm incrementing the sequence number to 39, and I am removing the existing signature. So with this object, now I can save it in a new file. So for that, I will call again my trusted list facade and marshal my JACB object. into binary output stream and then store in the unsigned trusted list XML. So let's try the example. So I printed the content of the edited trusted list in the console, and we can see the edited sequence number. And here is the trusted list file, and we can see that I removed the signature. So we are no signature, and the original file was this one. So at the end of this file, we can see a signature. So with the code snippet here, I remove the signature, then store it, the edited trusted list in the new file. Now, in the next example, I will show what happens when you try to load the invalid XML content. So for this purpose, I created a broken version of the finished trusted list where I commented a mandatory tag, this one. So I removed the tag, and we will see together how DSS will react. So with the default unmarshalling method, the call will fail. So here I expect to get an unmarshal exception. So I will print the exception data in the console. And then in the glitch facade, you can add an additional method, unmarshal, where you can explicitly ask to DSS to skip the validation against the XML schema. So with this line, DSS will be able to load some object in the JSP representation, and then I will be able to fix the trusted list. So I will fill again the version identifier, and then we'll be able to marshal my fixed trusted list. Let's run the test case. So in the console, we can see the exception. So it says that the TSL version identifier is expected. So it's a missing tag in the broken file. Now I will show my last sample here. You can also only validate the XML file without loading it fully in the JSP representation. So here I can validate the file against the XML schema directly. So here I will use the trusted list util and then call validate again XSD. In some use case, you may want to validate against some additional trusted list. So we can imagine, for example, you are trying to sign a document which follow an existing XML schema. So here you can ask this method with additional XML schema, so you will be able to validate your Gss signature with the Gss XML schema, and then your additional file, and then validate that the XML is truly conformant. That's all for this first example. Now I will show how to use the XML style sheet to generate, for example, the detail report in HTML or PDF format. So for this purpose, I will firstly load the denoted data. So the denoted data is an XML file which contains all needed data for validation process. So I will firstly load it with a similar class when I explained it in the previous sample. So here we call the denoted data facade and then unmarshal my XML file. Then I will replay the validation, the complete validation process with the extracted data from the denoted data. So for that, I will instantiate a new default signature process executor. Will provide the denoted data object. I will ask him to pre-run with the validation time. So this line offer me the possibility to replay the validation at the given time. So I will get exactly the same result than the previous validation. Additionally, I also provide a validation policy. So in the validation policy module, you can directly load the default one. So this one is the embed default validation policy. If you go in the facade, you also have the possibility to load the used validation policy to validate trusted list file. Or you also can load your own validation policy with a path, an input stream, or directly a file. So now my executor is completely configured. I can call the execute method and then retrieve the report object, which contain the simple report, the detail report, and the HT validation report. So in the report object, you have a string representation or a JSP representation. To generate the HTML report, I will use the JSP representation and call the generate HTML report from the detail report facade. So in the module detail reports, you also can find XML style sheet. XML style sheet take an XML in input and then generate with some transformation. So in the first case, we will transform into an HTML page with some CSS classes. So in our implementation, we mainly use Bootstrap framework. So here is how to generate the HTML to be embedded in HTML page or in a pop-up. And the second example is how to generate a detail report from the same detail report JSP object. So for that, we use Apache FOP. So that's an open source project which is able to generate PDF file from XML and POP XML style sheet. So here I need to configure firstly the POP factory, specify that I want PDF as output, and then provide the result object to my generate PDF report method. we can try to see the result. So here I will store the HTML in this file and the PDF here. So let's try to run the code snippet. So in my target folder, I can find my detail report HTML. So here is the HTML representation of my detail report with some Bootstrap classes to customize the layout. And then we can find here the PDF report as you know it from the CEF bundle, for example. So everything is provided directly in the detail report Jack-B module. So you can go in the GitHub shop. So in the resource folder, you will find the XML schema and then the XML style sheet to generate the HTML and the one to generate the PDF. So everything is available when you add the dependency in your project. One more thing in this code snippet is this commented code. So from version to version, we sometimes need to enrich the content of the different XML reports. So sometimes you add some new data in the data or in the data report. So instead of directly using the Jack-B object, I recommend to use the wrapper class. So here it's a wrapper object that you can find directly in the data report Jack-B module. And with this class, we offer many methods to navigate within the Jack-B object. So you will find useful method, and the method, the signature of the method here will never change. So if we change the XML structure of the data report, we will ensure that the method here won't change. So you will be able to upgrade more easily the GSS framework in your integration. Next example. The next example is about the composite timestamp source. So when you are doing signature or signature intention, you will often use timestamp service, or external timestamp service, to produce timestamp token to extend your signature or to simply timestamp a document. But from time to time, that kind of service can be down or may have some issue. So in that case, if you do a basic configuration, you will configure only one TSP source. But if the source has some issue, your process will fail. So for example, here in the first snippet, I simply configured one TSP source, but this one will return error 500. But test TSA here, but this TSA will always return error 500, and I won't be able to timestamp my PDF document. So I will get a DSS external resource exception, and I won't be able to timestamp my document with this configuration. Let's try. So we can see that the test succeeds. So we catch it exception here. So in DSS, we offer the possibility to configure more than one TSP source with the composite TSP source. So with this object, you will be able to provide a map of several TSP sources. So for example, here I configured the first one with the error 500. So this one will fail. And the second one, we should succeed with a specific configuration. So I can configure, for example, to request nonce for this one, not for the first one. So here you can provide 1, 2, or more TSP source, and then call exactly the same code than before. So instead of providing the online TSP source, you can provide directly the composite TSP source. So DSS will try one by one until retrieving one timestamp token. I think you need to be very careful. If you configure a TSP, composite TSP source, you need to ensure that all sources can support the same digest algorithm. So for example, here I will do a timestamp with jar 512 digest that I will send to the different TSP source until I get the valid one. So let's try the example. So in the console, what we can see that the first TSP failed with error 500, and then my second TSP succeed. And we can check the timestamp head document. Okay, so you can see the document, and here you can see the timestamp. So you have a warning because I use untrusted. That's a timestamp. So that's all about the composite timestamp source. We can continue with the next example. So here we will talk about the visual signature with padded. So in DSS, we offer the possibility to do visual signature with text, with picture, with text and picture. We support the zoom capability. You can specify a rotation. DSS will also automatically detect the print rotation to correctly put the picture in the correct way in the PDF web PDF page. So here I prepared 3 different examples. So the first one is with a textual signature. So I will sign the hello PDF file with my Gss 12 store. So for that, I need to prepare the padded signature parameter. So here I'd like to do baseline B signature, so a basic signature without any timestamp, without any extension. Here I specify the signing certificate. specify the certificate chain. I can specify some other options like the location. I'm signing from Luxembourg here. And then I will configure the visual representation. So I will open my file, show where I want to add signature in my document. So here is my PDF file where I want to add the signature. I'd like to add the signature a bit below here. The origin of the PDF for the coordinate is the top and left corner. So here is 0, 0. So here I'm configuring my visual representation. So I'd like to put my visual signature on the first page with 70 each on the top, 150 on the left. Here I set the position. Then for the text, I'd like to add standard by plus human readable information, which will be extracted from my signing certificate. I will sign with a blue color and a sans serif font here. So all this configuration is added to the PADE signature parameter. Then I'm creating the PADE service and call the stateless method, so give the sign, and the sign document method. And finally, I will store my signed document in my target folder. Let's try the example. Okay, let's see the result. Here I can see my visual signature. So we sign it by and then the common name of my use signing certificate. Then in the next example, I will show how to do the combination of a logo and a textual signature. So I adapted a little bit the above code, added the signature to be used in my signature image parameter. So here I will use a logo. I changed a little bit the color of the text to use the same the use one in the logo. Here I specify that I want the text on the right side like the logo. And here I can specify that the text will be vertically aligned in the middle of the logo. And then I call exactly the same method than before. Let's try. Here is my signed document. And no, because I use a non-trusted service PKI. So here I commented a small line. So in the PDF box implementation of PADE, we offer several ways to create the visual representation. So the PDF default object factory is an implementation which will generate the signature as a pictures. So the current signature was generated with this implementation. I will show quickly. So as tech, you cannot zoom too much because you will start to see some pixels like this. The advantage of this implementation is to avoid to fully add a font file in the PDF document. So if you have some special character, you may need to add a specific font. So with this implementation, we will firstly generate the picture with the textual, with the text as a picture, and then merge to the logo. So you will get a picture, a complete picture with the representation, and then this picture will be added in the document. In alternative, you have the PDF box native. So this implementation will write the text with a PDF object. So we will include the font if needed in the PDF, and you will get a vectorial representation of the text. So I will rerun the test with the native implementation to show the difference. Here I can zoom the maximum, and I cannot see any pixel in my text. So the text is completely embedded in the PDF with PDF picture. And now the last example with the PDF visual signature. I will show how to add the custom font. So for example, I'd like to sign with the Pacifico font. So I downloaded the font in my folder, and then I will be able to use it. Here I can find my font. Let's try. So here you can see the same text with a different font. And I use the native implementation. It's all about the visual representation in a padded signature. Now I will explain how to configure the circuit verifier. So this class is one of the most important of the DSS project. But with this class, you explain to DSS which are your trust anchor, how to collect revocation data, how DSS should react in case of issue with revocation data, for example. So you have many configurations here. So I'd like to explain them more deeper. So I did some example for easy cases, and then I will explain some other option a bit later. For the first example, I have a certificate which don't contain any information about the revocation. So I have no URL for the OCSP responder, and I have no CRL distribution point within the certificate. So here I will show how to ask to DSS to fail when you don't find any revocation data or at least one certificate in your signature. So first of all, here I'm configuring the certificate verifier. Here I'm loading my trusted certificate. So I am injecting the key store content as a common trusted certificate source. So here in this key store, I have several OTA that I trust. Then I explain how to collect OCSP response with online OCSP source, for example, here. For the CRL source, I will set an online CRL source. And then in the certificate verifier, you have a set of alerts that you can configure. So the first one, this one, is on missing revocation data. So with that kind of configuration, I will ask to DSS to throw an exception and interrupt the extension process or the signature process when it meet the case. So for each missing revocation data, DSS will throw an exception. So for example, here I'd like to do a LT signature with my branch certificate. So the certificate here has no technical way to retrieve the correct revocation data. So with this line, DSS will fail and throw the alert exception. Let's try the example. And we can see no CSP found and no revocation found for the certificate with this keys, this ID. And the test succeeds, so I receive the alert acceptance in the example. So here was the example with an exception, but I can configure differently. So for example, here I will ask to DSS to add a log in the log file, or I can ask him to completely ignore the exception. So here it will continue and produce an incomplete LT level signature. We have a configuration by default. Configuration by default is an exception. So if we have any revocation data which is missing, by default DSS throw an exception. Next example is about revoke certificate. So I will do another signature with another certificate, and this one is revoked. So I have quite similar configuration than before, but I will configure another alert. So the alert on revoke certificate. So with this line, you ask to DSS to interrupt any extension process which meet any revoke certificate in the certificate chains. So here I'm trying to do LT level, and the last step will fail when we try to validate the certificate chain and collect the revocation data and so on. So here we will get a similar exception on the alerting. Let's try. So the sample succeed here. For the last configuration, that's quite difficult to illustrate with a concrete case, but they are quite useful for production. So you have an alerting for invalid timestamp. So we can imagine, for example, you receive an extended signature, but this signature contains a broken timestamp token. So you are not able to validate the token cryptographically. And for this reason, the signature cannot be extended. So if the signature is already expired with the invalid timestamp, you won't be able to extend it anymore. So here you have an alerting. So DSS will throw an exception if it finds a broken timestamp in the signed document. The next alerting is a bit more complex, but sometimes you may do LTA label signature directly. That's not a recommended usage if you use the same timestamp service behind. I mean, the first timestamp will be generated with the given timestamp service. With the LT extension, you will collect revocation data. If you are lucky, the revocation data will cover the first timestamp, but you will add one more timestamp token with the same service, but the second call won't be covered by the first revocation data. So here, with this alerting, we ask to DSS to throw an exception if at least one revocation data was not yet fresh for the last timestamp token. Now, the next example, also useful for production usage. Here, we can imagine we do LT signature directly in one shot. So I do my cryptographic signature baseline B profile. I extend it with timestamp, and then I'm trying to retrieve revocation data for the signing certificate chain and for the timestamp certificate chain. But if you are facing to a CRL, the CRL may not be fresh yet. So I mean, this update of the CRL is before the best signing time. So the best signing time is, in our current case, is the signature timestamp production time. So if the CRL is generated within the same second, cannot be sure that the CAL already cover your timestamp token. So with this alerting, you can ask to DSS to stop the extension process. So you can imagine, for example, we do a scenario with offline baseline profile signature. So you are at your customer office, for example, you only do a baseline profile signature without any internet connection. Then in the evening, you forward your document into extension workflow or preservation service, for example. And then in this service, we will firstly timestamp the document. And then 1 hour later, for example, we will try to extend to LT level. But with this configuration, that will fail until you have no fresh and updated revocation data for all included certificates. So you may imagine you have a cron job which try, for example, every day to extend and retrieve revocation data for your signature. So now the next configuration is check revocation for untrusted chain. So by default, DSS firstly build certificate chain. So it will collect the CA, CA N+1, the root CA, and only if he finds a trusted root CA or trusted certificate in the chain, it will collect revocation data. By default, DSS don't collect revocation data for untrusted sources. So if you want to force DSS to request untrusted OCSP server or untrusted CLI URL, you can configure and force DSS to request such kind of URL. Now I'm doing a quick introduction to feature of the 5.9 version of DSS. So in the 5.9 version of DSS, you will find this alert, for example. So this alert, you will be able to interrupt any extension process for expired signature. Expired signature, I mean expired for a basic signature. An expired signature is signature with an expired signing certificate. But if you already extended your signature to a T or LTA level, the signature will expire at the expiration time of the last timestamp certificate. So DSS will be able to detect expired signature. If the signature is expired, it's too late to try to extend it. Don't need to continue an extension process for such kind of signature. So here you will be able to configure DSS to interrupt the extension process. Now, one more configuration that we'll add in the next version of DSS is the way to configure which kind of revocation data you want to collect first. By default, DSS firstly try to call a CSP server. If no revocation data is found, we will try to download the CAL. But sometimes you may imagine that, for example, you are validating current signature from the same CA. Or, for example, in this case, that could be more interesting to download a fresh CRL and use it with a cache. So here you will be able to ask to DSS to firstly download CRL or firstly make a CSP request. So these two features are coming in the version 5.9 of DSS, which should be published next month. Let's continue with the next snippet. So now I will show how to configure trust anchor. You have several ways to provide your trust anchor. Before starting, we have 2 complete chapters in the cookbook. You have the official documentation on the CEF website. So here you can find a complete chapter about trust anchor configuration. We will see together with this snippet how to do the configuration. So the trust anchor configuration is at the certificate verifier level. So the class that we discovered together a bit earlier. So in this class, you have a set trusted certificate source method where you can provide one or more sources. So in the first method, I will initialize from the key store. So I'm creating a common trusted certificate source, and then I'm importing the key store content. I can do it manually. So I'm creating the common trusted certificate source, and then add manually my trusted certificate. So here I am adding OTA certificate in my source. And then we have possibility to provide trusted certificate from trusted list. So now I will explain more in detail the TL validation job. So before starting, the TL validation job takes a trusted list certificate source object to synchronize the trusted list content. In the version 5.6 of DSS, we completely rewrote the trusted list loading and added as much option as possible. So I will explain in detail the configuration in my example. So here I'm creating a job. I can set the debug mode. So the debug mode will display in the console the status of my cache before and after the synchronization. Then I am configuring an online data loader. So here I explain to DSS how to download my trusted list from the internet source. So here I'm asking to DSS to cache my downloaded trusted list in this file. So all downloaded trusted lists will be stored on this file on my file system. The online loader is configured with a cache of 0, so we don't consume the cache with the online loader. So when we call the online refresh, you will always call you will always retrieve the CL from the online website. The next configuration is the offline data loader. So here, that's a data loader where I will consume my TL cache directory. So with the same cache, and here my cache is unlimited. So if I call the offline loader, it will consume always in my TL cache directory. This configuration can be useful, for example, if you restart the DSS server and you already have cached trusted list on your server. So that will increase the server starter and firstly load quickly existing trusted list from your file system, and then later try to refresh with the online loader. So next, so here I'm configuring the trusted list certificate source. So that the object where the trusted certificate will be injected. Next, I have a synchronization strategy. Here you can explain to DSS how we should synchronize or not a complete trusted list. So by default, we accept all trusted lists, but you can configure differently with, for example, this class. So with this class, you can reject expired trusted list. So you won't extract any certificate from this trusted list if the trusted list is expired. Here you can configure the same behavior for invalid trusted list, so signature with a broken signature. And you have similar configuration for the list of the trusted list or the local. By default, we use the accept all strategy. So we fully load the trusted list and use all certificates from all trusted lists. But later in the validation process, you will get some warning and error for expired trusted list or wrongly signed trusted list. So I prefer to load everything and get more complete validation result. So I'm able to validate my qualified electronic signature, for example, but I will also report that the used trusted list is not correctly signed. Next configuration is the local source. So you can provide one or more local source. You can provide, for example, European local and one other alternative or homemade local. Now, how do we configure the local source? The local source requires some information like the location, so where is hosted the local. So the current URL is this one. You need to provide a certificate source. So here is the allowed signing certificate to sign the local. So in the current case, the key store which contain certificate that I found within the official journal. So the official journal will show quickly what is it. This one. In the official journal, you will find the different digest and any certificate for the local. I'm configuring DSS with a key store which contains all certificates from the OG, and then I set to DSS that I configure my local source with this version of the OG. And then in Europe, you need to specify the pivot support. So in Europe, we have some pivot local where we can introduce some more some new signing certificate. So with the pivot chaining, you are able to add or remove allow signing certificate for the local. Additionally, maybe some useful configuration, I can specify some predicate. For example, here on this local, I'd like to only load trusted list with the scheme territory equal to ES, so Spain, and XML file. So with this configuration, I will only load the Spanish trusted list. I will completely ignore the other one. Could be useful for some usage. For example, if you only validate Spanish signature. Second configuration, you can filter a specific service provider, for example. So here, I'd like only to validate to retrieve via firma a service provider. Can be you can customize the predicate. So you can extend. You can implement this method, this interface, and provide your own your own implementation. So if you want to filter, I don't know, with that number or something like this, you could create your own implementation of the predicate. So you have predicate for the trusted list, you have predicate for the trusted provider, and then you have predicate for the trust service. So for example, here we have a predicate which will only select trust service which had at least one granted status in his history or the current status. Here you have an implementation of the service certificate where we try to check the current status or the status in the history to see if that granted before or after the EIDAS. So the status changed in the trusted list. So DSS support both versions. So here are optional configuration which can be useful in some occasion. Then I coming back to the job. We configured the local source. We also can configure one or more independent trusted lists. The configuration is quite similar than the local source, but only with a trusted list. So for that usage, you will provide an URL, allow any certificate, and some customization like the predicate. And you can, for example, load Peruvian trusted list like this. Next, we can configure some alerts. These are optional, but they can be useful in some cases. For example, for the local, we can configure OG URI alert. So with this, we can configure an alert when the OG URI is updated in the local. So if DSS detects any desynchronization in production, You can ask to DSS, for example, to add a log in the console, or you can create your own handler and then configure DSS to send an email to a specific mailbox, for example. The second interesting alert is a detection of a local location change. So in the local, you have an URI to this URL. But if the Open Commission decide to change the local location, they will update the specific location in the local itself. So with this alert, we can raise an handler when we detect a local location change. So you can also configure, for example, a mail sending or something else like this. We had also alerting on TL if you want. So for example, here we have a detection for signature error, so invalid signature, for example, or for the TL expiration. So you may imagine that you want to monitor a specific trusted list for your country, for example. You can ask to DSS to send email or something else when they detect expired trusted list or when it detects invalid signature and so on. So here I illustrated the different configuration for the PL validation job and the different way to configure a trusted certificate source. So we quickly run the test here. So here we can see the trusted list loading. And then we can see the debug mode enable or here is enable. So you have the data, the status of the different cache. So in the TL validation job, we use 3 different cache. So we have a cache for the download, we have a cache for the parsing, we have also a cache for the signature validation. So now with the TL validation job, we do the strict necessary. So for example, if a new trusted list is published, we will download, parse, and validate the signature. If a new local is published, we will detect the different change. So for example, a new signature state for a given trusted list, we will expire the cache for this given trusted list and then only revalidate the signature for this trusted list. In the previous versions or version 5.5 before, we systematically did everything for all trusted lists. So we improved the performance with this refactoring. So here we can see that everything is synchronized, and then after the synchronization, everything is synchronized. Next example, I will show how to do a certificate validation with DSS. So in DSS, you probably already know the sign-in document validator. So for the certificate, we did quite similar behavior. So you have a certificate validator where you can provide your certificate. Then you need to configure the certificate verifier with your trust info, with the way to collect location data, and so on. So quite similar than before. You also can specify, for example, the token extraction strategy. So here you ask DSS to add base64 URL, base64 encoded certificate or revocation data in this case. So you have several strategies here. So you can extract everything. So here we will extract certificate, timestamp, and revocation data. You can ask to extract certificate and revocation data, or only certificate, or only timestamp, as you want. By default, we extract nothing. So the default configuration is known. And then with my validator, I will call the validate method. I can provide my own validation policy. So by default, with the validate method, I will use the default DSS validation policy. So the validate method returns a certificate report which contains the different reports, or the simple report for certificate, the detailed report which contain the follow step for the validation process, and the HC validation report. So let's try the example. So here I am trying to validate a revoked certificate. I'm trying to validate a revoked certificate against this trust anchor. So let's see the result in the console. So here we can see the simple certificate report, which contains information about the certificate chain. So here I can find my revoked user with the revoked information here. If I had used Verifier certificate, I would get the qualification status at the certificate issuance or at the validation time. So if I add a loaded trusted list and a qualified electronic certificate, I would get qualification status here. Here you can see the different certificates in the chain. You can see that the certificate is revoked. Here you have a detailed report, so all follow steps in the validation process. And you can see the detailed report, the genetic data here. And the genetic data, you have the certificate. And you can find here the base64 encoded information for the certificate, and a bit below for the revocation. Up here, for example. Up here, I have the base64 content. So here, that's OCSP response. So I can quickly check rapport, for example. So you can decode the content like this and dig more in detail if you need. So here it was the example about the certificate validation. Let's continue with the timestamp validation. So in this example, I will show how to validate the timestamp token with DSS. By timestamp token, I mean token, not a timestamp PDF, or I'm only talking about the token, so the cryptographic token. So for this example, I will do a timestamp with my test PKI. So I will call my test timestamp service and generate a timestamp token with Gss SHA-256 of my LOSF document. And then I have two possibilities to validate such kind of token. I can call directly the signed document validator, which will automatically detect the timestamp token and validate the token as a token. Or you can directly create the detached timestamp validator. So this implementation of the validator is only to validate timestamp token. And you have the possibility to delegate the job to DSS with the signed document validator or to select directly the correct implementation. So then the validator, I will provide my timestamped document as a detached content to be able to validate the message imprint against the original data. Then I'm configuring the certificate verifier as usual, and then call the validate document method. Here I also can provide my own validation for it. So here by default we will use the GSS validate. Let's try the example. So the print method print all XML content in the console. So in my console, the first position I have the genetic data. Then I can find the detailed report. So all follow steps from the HE 119, 102. Then I have my simple report, which contains the summary of my validation process. And then I can see the HE validation report. And in the simple report, we can see that I have a timestamp which is valid. I had no qualification because I didn't use any list and I didn't use verified timestamp for this example. But work similarly than for signature. Now we can continue with the next example. So the next example, I will show how to translate the validation report into your language. Wait, sorry, not the correct discuss. So in this example, I will show how to translate a detailed report and a simple report. Yeah. So you will see that very simple. So a few versions ago, we introduced a new module in the DSS project. The module is called DSS Internationalization. And in this module, you can find the DSS message property file, which contain all English label that you find in the detailed report and in the simple report. So this last day we received a contribution with an Hungarian translation, so I will use it for my example. So I added the translated message in Hungarian. So here I can see the different translation. So the file is named DSS message underscore issue.property. It will be automatically detected by DSS when you add the local. Here I'm asking to DSS to use the Hungarian local. So here I am simply validate the document with empty circuit verifier and the Hungarian local. I will display the detailed report in the console. Okay. So here we can see the different message for the different status explanation. Everything is translated except the different indications, sub-indication, which are provided by HC. The HC standard define the status and sub-indication. So we don't translate them. So here you can see how easy it is to translate your different report into your language. So now the next example, I will show how to call SOAP and REST interface of the DSS project. So quickly in the GitHub, you can see, for example, here the different module for the validation. So you have web service for the signature validation, we have web service for the signature creation. You have web service with the signature token connection. So you can expose the FSM with this web service. And you have the timestamp web service here. So you can expose simple API to request timestamp. Okay. So for this example, I started a bundle. So here you can recognize the GSS demonstration bundle that you can download on the CEF website. And here you can find the different web services. So you have web service with the SOAP, and you have web service with REST. Okay. Then in the cookbook module, you can find the Postman example. I go there. You can see a complete Postman project where we show how to call each API with REST. You have similar example with SOAP UI. So with SOAP UI, we try to call with SOAP and with REST. in my code sample, I will show how to configure Cxf with Java. So you can call this this service with any language you want. So with Python, with C++, with any language you want. Here I will show how I do it with Cxf. So Cxf is an open source project to call SOAP and REST web services. So I'm configuring for the SOAP call. So I need to create a Gss factory bin where I set my interface. So in this interface, I define the different methods and which are the recognized DTO. So for example, when I will call getDataToSign, I need to use this DTO and it will return such kind of DTO. So with Cxf, I will be able to automatically use Java object with this factory. Here I enable mtom. So mtom offers the possibility to send document as attachment and not within the main SOAP and block. Here I specify the URL call, so I will call my local server. So I will call this URL. Here I configure some logger, so it will display in the console a different message. And then I'm creating my SOAP client, and then I can sign with DSS. So I did the signature creation remotely. So the local server will be responsible to create the data to be signed and to sign the document. The cryptographic signature will be done locally with a token. So here I quickly configure the Gss signature. So the configuration is quite similar than with the DSS project, but with serializable DTO. So I the SOAP call. So here in the console, what can we see? We can see the first request for the data to be signed. We can see the response. So the response. Here we did the cryptographic signature locally, and then we have the second request to incorporate the signature value in my document, and then I get the server response here. If I check the log of my server, we also can see input and output message. Let's continue. So here was the example with the SOAP implementation. Now we will do similarly with the REST interface. So here is how I configure Cxf to call my REST interface. So I will call this URI. So here I'm configuring Cxf. I'm creating Gss client to call this URL, map the URL to this interface. So here is an interface that you can find in the source code of GSS. It explains how to bind the response and the request. I configure JSON, so for REST you need to parse into JSON. So in Java you can use JSON for it. Then I'm configuring the logging to get the different message in the console. And then finally I'm creating the REST client here. And I will do exactly the same code with the REST client. So I will sign cryptographically sign locally, and then compute the signed document on the server side. Let's try the example. So similarly than before, we can see the two requests with the JSON message here, and we can see the response with the JSON response again. On the server side, we have similar log, where we log all input and output requests. Next example. Here I will show how we can use this signature of digest. For example, here I will do a signature of a document, but I don't want to share the content with my server, so I will do a digest signature. So for that, I'm creating a digested document, and I add the digest on my full document. So here I'm filling the digest document with SHA-512 type. Such kind of signature are only possible with Gss packaging. So that will create a new file with the signature inside. So here I'm doing with the Gss service. I'm configuring the Gss signature parameter to create a baseline B signature, so basic signature. I'm configuring the sign certificate chain, and here I will set the reference digest algorithm. So here that's the digest that I use to do my digested document. You can specify a different digest for the cryptographic signature. So for example, here I'd like to do my signature with SHA-256. It can be different. So after that, I have my Gss service. I'm calling get data to sign. That will return to be signed. So for Gss, the to be signed is an XML. So concretely, that's the canonical signed info. So I will display in the console here. So usually you do such kind of signature. So the whole signature on the token side, the signature globally is a combination of the digest and encryption. So with this method, I will do a complete signature of the token side. Alternatively, you can decide to don't send the whole XML. So if you have, for example, reduced bandwidth between two servers, you may firstly digest the to be signed document, the to be signed content, and then ask to the token to do a raw signature. So a raw signature is only an encryption without any digest process. So here I'm computing the digest value, and then I will call my token with this digest. In DSS, you also can find this method that will help you to validate the retrieved signature value to be ensured that the signature is correctly valid. So you didn't produce a broken signature value. And then when you are sure, you can call the assignment method. Let's try. So here I did an example with a CDSA. So in my console, I can see the content of the design. So we can see the signed info with canonicalized format. And then the signed data, digest that I try to sign is this one in hexadecimal. I can show quickly the validation in my browser. So that's a detached signature, so I need to provide the original document as parameter. You also can only provide the digest. Like to don't send the file, so I can ask to the browser to compute the digest and send. So the demo here trust the test PKI and also trust the PKI, so you can see that the signature is valid. Now we have a similar code with Gss detached format. The special things is the RSA signing keys here. For that, you need to wrap the digest value into an SN1 structure before calling the sign digest method and calling. Okay. We can see valid signature. Can be useful in some use cases. I don't know if we have enough time for the really last example. Do you have any question in the chat? I didn't see any question. Okay, I don't see any question. So let's continue quickly with the last snippet. The last snippet is how to easily sign a trusted list. So trusted list signature can be quite complex. You have many constraints in the HC 119612 standard. So it requires a specific format, requires some specific attribute, and so on. So we introduce a signature parameter builder to help you to configure correctly DSS to produce such kind of signature. So you create a signature parameter builder, provide your signing keys and the trusted list that you want to sign, build the Gss parameter, and proceed as usual with the 3 statelet method. Let's try quickly. Sign it here. Okay. And now formatting to show the signature. Here, that's a signature for the list. So you can see the envelope signature confirmation, which is mandatory by the standard. You can see only one certificate. You cannot include more than one certificate here. We have the signing certificate V1, so that's the old version of Gss. So we cannot use the signing certificate V2 here. And finally, we can find an empty URI here to prevent XML wrapping attack. So that's all for my example. Now I will show some information about the next version of DSS. If you have any question, feel free to ask them in the chat. So here you have the main new feature or bug fix. The first release candidate should be published on July. We will send a release candidate for compliance and security testing, and then we will publish final version in August or September. Here you have a non-exhaustive list of main feature, bug fix, and the removed stuff. If you have no additional question, I will say thank you very much for your attention. And we remain at your disposal on the Jira. If you have any question, so feel free to create ticket. If you have any suggestion or any bugs to report, feel free to create a ticket.
Wonderful. Thank you very much, Pierre, for that very comprehensive presentation. Before we conclude today, we wanted to get some information from participants at today's session on what might be interesting in terms of upcoming sessions. So sorry that my camera is off. I think it will potentially affect the quality of my video stream. So I would ask if Sophia, if you could just share the Slido page, and I will share a link to Slido and the code. And what we're going to do is we're going to ask just some questions on what would be useful for upcoming events. So just bear with me for 1 second. Hang on, whoops. What we ask you to do is to go to slido.com and put in the code that I've just added here in the chat. I'll also put the URL for Slido in the chat. And all we want to do is just get your ideas on some upcoming events. So it won't take 2 seconds, and then we can all get on with our afternoon or our evening. So voila, thanks, Sophia. So you can see here the Slido page. The code goes in the top as joining. And then you will see a question that we have prepared. It's one of 3 quick questions. Okay, so the question is, are you interested in a bug bounty session? And I'll give it a minute just for people to start, for people to make it over to the Slido platform and to add the code. On the screen, we can just see an example from Sophia, so I will let people. Actually, Sophia, what I'll do is I will share my screen because I think I can, because I see the results. So let me share the screen, perhaps, and then you can see the results. Okay, I'll just share my whole screen. Okay. Okay. Do people see my screen? I can't tell because I'm sharing.
Yes, we can see it.
Brilliant.
So,
Okay, we've got 9 people. We have more. We have about 35 people still in the call, so I'll give it a few more moments. Yeah. Okay. Tollis, are you keeping track maybe of the responses and the level of enthusiasm, perhaps? Because then I guess it'll be yourself taking this forward in terms of what the next steps are for events around the building block.
that's correct, Tom.
Perfect. Okay, I'm going to move on to the next question because we're at time and I know that people have stuff to do. So I'm going to switch questions for those of you who are in the app. Okay, so the next question is coming on. I hope it works for those of you in the app. If not, just let us know. So the next question is, are you interested in a physical meeting in Brussels when the situation permits? Okay, that's about the same number of people we had for the previous section. So we'll take note of the relative level of enthusiasm there. And we'll move on to the last question. Everything has been done exceedingly well so far. Not for now, very good. Okay, I'll leave this on to give people time to type their responses. I'll leave it for a minute. I would just do a quick reminder that there is a link to a satisfaction survey. It only takes 30 seconds or 1 minute. If you click on the link and let us know what you think of the webinar. We do this for all of our webinars around the CEF building blocks, and obviously it's a big help in terms of us organizing webinars, and hopefully obviously means that we have
And there is a very interesting answer here, Tom. Could we get some time to think and get back? Of course, don't hesitate to reach us via our fax or mailbox. And of course, your feedback is highly welcomed.
Thanks, Tolis. Sophia, could you share the functional mailbox in the chat? And you can all find the functional mailbox in the invitation to the event, actually, that appears in your email agendas. So indeed, welcome to get back to us whenever.
That's correct, Tom.
Yeah.
Thank you very much, everybody. I see people start leaving because there are other meetings planned, I think, for everybody here at 5 o'clock. Thank you very much for organizing this event, Tom and Sophia, and of course, Pierrick, for this very detailed presentation that you performed. And many thanks to all the participants that they remained for the whole duration, let's say, of this webinar. And hopefully we will catch up together soon. Have a lovely evening, everybody.
Thank you, Tolis.
Thanks, Tolis.
Thank you very much.
Bye.